understand energy more completely, we have to now add this concept that's referred to as work. So we'll first look at it from a conceptual point of view, and then we'll look at some of the mathematics behind it. To really get the idea across, you can take a look at this example right here. So we have three cases, A, B, and C. In case A, we have a ball at rest at the bottom of a flight of stairs. At some point in the future, the ball is on the second step, and at some point after that, it's all the way at the top of the stairs. Now, the ball is at rest in each of these diagrams. So I'm sure you've seen something like this happen in your life at some point. You come along, I don't know, something's been moved up to a shelf somewhere, or something is slowly moved up from one floor to the second floor of your house, something like that. So you haven't seen what happened, you just know that this object has been moved. All right, it's not groundbreaking, but it is important to understand what happened in terms of energy, or more specifically, what this idea of work is. So to try and get across the idea to you, let's analyze each of these very quickly in terms of our energy bar charts. So if we look at case A, it's on the ground, it's at rest, so it has no, kinetic energy, it's not moving. It's on the ground, it has no height, so there's no gravitational potential energy. So when it's at the bottom here doing nothing, it has nothing. There's no potential to do anything, there's no velocity, so it has no energy whatsoever. If we take a look at the second case where it's been moved up to the second step, we can now see it's the second step up, so it's gained some height, so there's certainly some GPE. It is not moving at all, I still have no kinetic energy. If we look at the last case, case C, it's now at the top of the steps, so it has more GPE than it had before, still not moving, no kinetic energy. Now this should certainly throw you off a little bit, because how in the world can I have nothing, then 2 blocks of gravitational potential energy, and then 4 blocks? This completely violates what we've discussed is the law of conservation of energy. You cannot create or destroy energy, so how did 2 or 4 blocks get created in this case? And it's a little bit tricky, but it didn't actually get created. The most important thing to realize is in the universe, if something gains energy, something else must have lost energy. So the law of conservation of energy still holds true. We just don't see the thing that lost energy here. Something had to have come along and given this ball its energy. That's what the law of conservation of energy states. So if we think about this, like what could have happened in between? Well, something must have come along and added or subtracted energy, and that's what we refer to as work. Work is the addition or subtraction of energy by some outside force. Now, we didn't see what happened here, but we can kind of infer what might have happened. What likely happened is that somebody came along between A and B, they picked up the ball and they placed it on the second step. And then again, someone came along, picked it up from the second step and moved it to the top. We're just going to look at A to B. So we know, even though we didn't see it, that somebody came along and moved this, and that's what happened here. The ball gains energy because it now has more GPE when it's on the second step, but somebody must have physically come along and moved this thing. If you think about working out, going to the gym, anytime you pick something up and move it, you are burning calories. That's what people do at the gym. They spend a bunch of time picking things up, burning calories, which is a form of energy, so they leave the gym with less energy than they walked in with. So we just have to realize that the person loses energy because they physically gave some of it to this object. They had to burn some calories to get this thing to move, and those calories, that energy, must have gone into the ball in terms of gravitational potential energy. You can never create or destroy it, but one object can lose, in quotes, because we're not losing any energy, it's just transferring from the person into the ball. Now that begs the question, how do I figure out if energy is added or removed? So in this case, it kind of makes sense. A person came along, they moved it, they burned calories, okay, fine. But in any case, how can I figure out which object is gaining the energy and which is losing? And to do that, you just have to consider 2 things. The force that the objects experience and their displacement, or the direction that they're moved in as a result of that force. The easiest way for me to describe this is to show you a few examples. So I'm going to show you 2, explain the reasoning behind them. Then I'm going to give you 2 more examples, and you can pause the video, try them out yourself, unpause the video, and just see what the solution is, see if you did it right. So if we take a look at the ball here, what I mean by force and displacement is that when it was at A and somebody picked it up, the person pulled up on it. Okay, so the person pulled up, the ball moved up as a result. When these 2 go in the same direction, you are going to gain or add that energy. So the force acting on the ball pulled it up. As a result of that force, the ball went up. Those 2 act in the same direction, and that is why the ball gained energy. If we look at the person, yes, they're lifting the ball up, but while they're holding the ball, gravity's trying to pull that down. So that means the ball is technically trying to pull their hand down. It's like Newton's third law. If the person pulls the ball up, then the ball pulls the person down. Okay, so the ball is attempting to pull the person down. The person is clearly stronger, so the person is able to overcome that. And even though the person is being pulled down by the ball, they still move upwards. Okay, as they pick it up, their hand moves up. The ball pulls down, but their hand moves up. Those are opposite directions, and therefore the energy is lost. To figure out if the object gains or loses energy, you simply look at the direction of the force acting on it and the direction that the object is moving in. Same direction, gains energy. Opposite direction, it loses energy. So if we look at the first example here, we have, a soccer ball. Yes, it's a foot. You can make fun of me later on. Please, not while I'm around, not to my face. The foot kicks the ball begins to move. So if we draw one of those little diagrams, for the ball, during this interaction, the ball is pushed by the foot to the right. The ball moves to the right. The force and the displacement are in the same direction, so the ball gains the energy. During this interaction, yes, the foot is still moving forward through the ball through that pass. However, if the foot pushes the ball right, the ball pushes the foot left. So the force and the displacement are in opposite directions, and that person loses the energy. They burn some calories in order to get this ball to move. They lose the energy. Where did it go? Into the ball in the form of kinetic. If we look at one more example, stationary ball, moving ball, they collide with one another. They continue to both move, but ball 1 slows down, ball 2 speeds up. If we look at ball 1, okay, well, ball 1 pushes ball 2 to the right, ball 2 pushes ball 1 to the left. So ball 1 is being pushed to the left, but is continuing right after the collision. Those act in opposite directions, and that loses the energy. Ball 2, during the collision, is pushed to the right by ball 1. As a result of that force, it moves right, and therefore it gains the energy. In an interaction between any two objects, one will always lose and the other will always gain that energy. Law of conservation of energy. All right, so take a look at this example. I'll describe it. I will allow you some time to pause the video, figure out what you think happens, and then we'll take a look. So you've got a nail, it's stationary. A hammer comes along, slams into the nail gets driven into the wood, and then the hammer kind of, for the most part, stays at rest where it is. So pause the video, think about this for a second. Which object gains the energy? Which object loses it during this interaction? And why in terms of force and displacement? Pause the video, try it out, unpause it, and see if you've analyzed this correctly. All right, so if we take a look at this, during the interaction, the nail is forced down by the hammer. As a result of that, it is pushed down into the wood. These are both going in the same direction. Therefore, the nail gains the energy in the form of kinetic. It wasn't moving, and then it was driven down into the wood. So it moved, so it gained kinetic energy. The hammer pushes down on the nail, so the nail pushes up on the hammer during that interaction. However, the hammer still continues down with the nail. Therefore, it loses that energy. Hammer slows down during the interaction. Nail speeds up. Kinetic energy from the hammer was transferred into the kinetic energy of the nail. If we look at the last one, example 4, a little bit trick here. Block is sliding across a frictional surface, eventually comes to rest. So we're dealing with the ground and the block. Draw your force and your displacement diagrams, figure out which gains, which loses, and pause the video, unpause. When you're done, figure out if you've done it correctly. All right, if we take a look, well, the block is moving to the right, but friction pushes it to the left, but the block is sliding to the right. Therefore, the block loses this energy. It had kinetic, it loses all of it. The floor is being pushed to the right. If the floor pushes the block left, the block pushes the floor to the right. The floor is technically moving to the right. You wouldn't notice it because the earth is so massive, but if the block is pushing the ground to the right, it will move to the right. As a result, the floor gains the energy. Now, how could it gain that energy? Because the floor is really not moving in any noticeable way. Well, if you run your hand across a frictional surface, you will notice something. Your hand and the surface heats up. So in a case like this, the kinetic energy that the block lost technically would have heated the ground up. It's the same reason why if you slam on your brakes while you're driving, sometimes you'll see like those tread marks on the roadway. That generates enough heat during that frictional interaction that some of the tire actually starts to melt slightly. So in a case like this, same process applies. Look at the force, look at the displacement, same direction, it gains energy in some form. opposite direction loses energy in some form.